Hello, today I want to talk about how to use logistic regression to do prediction. So, what is logistic regression and when do we use logistic regression? Actually, when we need to predict binary outcome, we will use logistic regression. For example, we can predict whether a student will pass or fail in his exam, or whether an interviewee will be employed by his or her new employer according to his or her past data such as his academic results, working experience, height, sex, and so on. Before going deep inside the Python code implementation of logistic regression, let us focus on the basic principle of logistic function first. As you can see here, there is a logistic function, and the output is from 0 to 1. If you learned digital electronics or computer engineering before, you will know what binary variable is. Here, 0 means false or fail, 1 means true or pass. It doesn't necessarily mean good or bad or something like that. 1 just means the event will happen, and 0 just means the event will not happen, just like that. It doesn't necessarily relate to the good or bad, But what is this graphical function mean? Firstly, you can try it yourself. You can substitute any value of x and to see what the outcome of y is. You will see that the output y is from 0 to 1 no matter how big or how small x is. In other words, when x tends to negative infinity or x tends to positive infinity, the output will always from 0 to 1. Just like this function, from 0 to 1 the output. Okay, if you have understood what the basic principle of logistic function is, let us go deep inside the Python code implementation for logistic equation. As you can see here, there is a Python code written for the logistic regression. And candidate is the data set. What we would like to do here is to predict whether the candidate will be admitted according to his or her past results such as GMAT, GPA, and working experience. In other words, we would like to predict whether the new employer will employ this candidate according to his or her past results and working experience. Here you can see the data of admitted column is either 1 or 0. In other words, 1 means he or she will be admitted, and 0 means he or she will not be admitted by the new employer. But anyway, the first step you need to do is to process the data set called candidates. Here, there is 4 columns inside this data set: GMAT, GPA, work experience, and admitted. And the first 3 columns is the independent variables, which are used to predict the outcome. And the admitted column is the outcome we want to predict. But anyway, how do we format this raw data set? We can do it in a very convenient way by using a written module called pandas. As you can see here, I have imported pandas as PD, which means I can call this PD object to process my raw data set. Here you can see I have written the code as df equals pd dot data frame candidates column equal to GMAT, GPA, work experience, and admitted. But what does this code mean? This code just simply means your dataset is candidates. You need to put the name of the raw dataset in the first parameter of the built-in function data frame. After that, you need to specify the columns. Here, I have specified the columns as GMAT, GPA, work experience, and admitted. But still, the computer do not know which column is the outcome and which columns are the independent variables. Therefore, you need to specify it. Here, I have specified X as GMAT, GPA, and work experience, which means the data cell inside these three rows are independent variables. And also, I have specified the admitted column as Y, which means the data cell inside the admitted column is the outcome which wants to be predicted. But only specifying the independent and dependent variable and columns are not enough. You need to tell the system how big is your training dataset and how big your test datasets are. But before going inside to learn what is training dataset and test dataset, let me explain what training dataset is and raw dataset is. So-called training dataset is simply used to allow the machine to learn the patterns behind the raw dataset. For example, here, a raw dataset is called candidates, which consists of 4 columns. And as mentioned before, we want to use the candidates GMAT result, GPA result, and work experience to predict whether this candidate will be employed by his or her new employee. It's not difficult to see if the work experience of or his academic results are higher, the chance of being admitted will also be higher. But the machine is not a human being. The machine needs to learn the pattern behind the raw data set by the algorithm or code we have written. Therefore, we need to provide certain amounts of data as the training data set for the machine to learn the patterns or rules behind such a data set or raw data. So now you understand what this sentence means. The training dataset is used simply allows the machine to learn the patterns behind the raw dataset. Okay, I believe now you understand what training dataset is. But what is test dataset? Again, test dataset is just used to validate whether the generated patterns by the machine for the raw dataset is accurate or not. In other words, test dataset is used to tell us how accurate the generated patterns or the predicted outcomes is. But how can we split this raw dataset into training datasets and test datasets? We simply need to do that by a built-in function called train test split. Again, this function is a built-in function. Therefore, we need to import it. But which module does this built-in function belong to? Let me show you now. As you can see here, the built-in function train test split belongs to the module called sklearn.model selection. So we need to import the module called sklearn.model _selection to use and imply this built-in function called train test split. Okay, now you understand where does this built-in function come from. Okay, but how can we allow the machine to learn the patterns behind the independent variables and the dependent variables? Since we have already split the dataset into training dataset and testing dataset, and the size of the testing dataset is 0.25. In other words, the test size is 25%, and the remaining dataset which belongs to training dataset is 75%. Okay. But only splitting the dataset into training dataset and testing dataset is not enough. We need to fit the model. In other words, we need to allow the machine to learn the pattern behind the independent variables called X-train and the predicted outcome variables called Y-train. Therefore, first we need to declare a variable called logistic regression, which equals to the building function called logistic regression. After that, we can apply this object or variable directly to fit the X training variables and the Y train variables. In other words, this code is used to fit the model and allow the machine to learn the relationship behind the independent variables and the dependent variables. But before applying the training dataset and the test dataset, which are used to predict the outcomes we need to know, we first need to validate and verify how accurate this model is. If you have learned data science or machine learning, you will know a technique called confusion matrix. Confusion matrix just allows you to know how accurate the model is. But why do we use confusion matrix and when will we use it? Confusion matrix allow us to know how accurate the generated model is by the machine learning. In other words, a confusion matrix is a table that is used to describe the performance of a classification model. It allows the visualization of the performance of an learned algorithm. Here you can see a picture. This is actual value, which means true value. And this is a predicted value. It may be true or may not be true, but it is just predicted by ourselves. And what does true positive mean? True positive means the actual outcome is very true, and what you predicted is also true. But what does false positive mean? False positive means you predict the value as true, but the actual outcome is false. For example, you predicted that the candidate will get a job or employed by his new boss, but in fact he is not. And then this is called false positive. And what does true negative mean? True negative means the actual outcome is false or negative, but also you predicted the outcome as negative or false. Then this is called true negative. For example, you have predicted that the candidate will be rejected, and in fact, he or she is actually also rejected. So this is called true negative. Here you can see the accuracy of the generated model is 0.8. In other words, the accuracy is 80%. But how can we output the accuracy of the model? We just need to apply matrix.accuracy score, y-test, and pre-RED. But what about the confusion matrix? As you can see here, the true positive value is false, and the true negative value is also false. True negative or true false, true positive false, true false positive 1, and false negative is also 1. In other